Good afternoon, students. Okay, let's start the class. Now, in the previous classes, we discussed about file input and output, right? File handling. Okay. Now, today we will discuss about the collections and the threading topic. Yesterday we discussed about all the IO packages and what are the classes present in the IO. Okay, how we can read the file and how we can create the file, how we can append the file. Okay, and we have done some small examples to how to write and how to read the file in the Java by using the java.io classes, and we use the IO exceptions to handle the any exceptions like file not found. Okay, now today we will discuss about the collections and the threading. 1 second. Yeah. What I said, collections, right? Okay. Now, what is actually collections? Like we can call it as a collections framework also. Collection is like like we are creating object, right? So the collection is an object, okay, that will group the multiple elements into single one, okay, into single unit or single element. So a collection is an object that groups multiple elements, okay, multiple elements into a single unit. Okay, and then that unit will help us with storing the data and retrieving the data, or to manipulate the data, or you can communicate the aggregate data. Okay, why we need these collections means in array, when we create the array, it is in a fixed size. So when you want to store a dynamic values, okay, dynamic in the nature, so you can use this collection. So collections can be the major collections is a group of a multiple elements. Okay, it will group the multiple elements into single unit. So it will be useful for retrieving or to manipulate or to communicate with the data. So because of arrays of fixed size, we use the collections to get the dynamic in the nature, and it also provide the inbuilt methods, okay, to manipulate the data in the collections. And we have common methods in the collections. Okay, so collections, in the collections we have list, okay, and we have set and we have queues. Okay, also we have map, but it's not a child of the collections, but it is in a very useful collections. Now, second, let me write a collection. Collection is a group of objects, okay, a group of objects, a group of, like what we can say as a, is a collection is in a group of an object that groups, okay, it is also group of an object, and we can call that group multiple elements into one unit. Okay, into one unit, it helps in storing, retrieving, retrieving, manipulating and communicate data. communicating data. And why we use, because arrays are fixed, so to want to store the more elements dynamic in the nature, so we use collections. Okay, so I can give one more definition for this. Let me give it here. We can call it as a collection. A collection is a group of objects. Okay, group of objects known as elements. Bundled together in a single unit. Okay, bundled together as a single unit. This is nothing but just, this is elaborated one. This is a simple one. A collection group of objects, which means it's groups of multiple elements into single unit, so it will store and retrieve. So this is bundled together, okay, into a single unit. So Java collections frameworks provides interfaces and the classes and also the algorithms. Okay, Java collection collection framework provide we can as a interface. Okay, so interfaces are nothing but, as I explained, list, set and queue. Set, queue and etc. Here we have in this. Okay, and we have the classes in that. And what are the classes? Nothing but array list is a class, as set is in a class, and linked list, etc. Okay, and we have the algorithms algorithms as sorting algorithm. Okay, sorting and shuffling. Okay, shuffling, and we have more, but etc. Let me give the exact one. Okay, why we use collections instead of an arrays? Okay, we collections and arrays are same. Okay, those are the group of elements into a single unit is a collection, but that for particular array we have the fixed size for an arrays. Okay, fixed size for arrays, but for collections, okay, for collections have dynamic size. Okay, dynamic dynamic size dynamic size. So in the arrays we didn't have built-in methods, okay, for searching or for to sort the array or to search the array. Okay, I have seen. And for the collections we have a like a rich set of built-in methods. In the collections we have lot of built-in methods to for search or sort for to any operations. Okay, for in the arrays, but we arrays are also those are also store the elements, but those are fixed size in the nature and there are no built-in methods for the searching and sorting. But in the collections we have the dynamic size. Okay, we can store the dynamic size and there are a lot of built-in methods in the collections. Okay, now but arrays are not part of the util packages, but the collections are the part of the util packages. Okay, and the arrays have the poor memory utilizations, but in the collections we have the better memory and better data structure for the management of these collections. Okay, so this is where we use, instead of arrays we use the collections. Okay, these are the key differences. When you ask why you are using arrays than the collections, you can say arrays are fixed size, collections are dynamic in size, we have more built-in methods in the collections rather than the arrays. Okay, and we and it is also not a part of the util packages. The collections are part of the util packages, and we have the better memory and data structure management in the collections than arrays. Okay, so arrays are the poor memory utilizations. Okay, so the key features of the collections frameworks are those are use common interfaces, and they are dynamic, and those are also support the algorithms like sorting, searching, reversing, and etc. And we can program to any interfaces, like I have explained, right? Interfaces we have list, set, queue. Okay, we can program to the interfaces like a polymorphic behavior, we call it as a polymorphic behavior. And it is also thread safe alternates available in the collections. Like if you want to synchronize the list, you can use a synchronized list method. We have the method known as a synchronized list method, or you can use a concurrent hash map. Okay, so alternates for the thread saves. So we in the collections we have all these features. Okay, so we use mostly collections. Now the hierarchy of the collections will be like first the first top level. Okay, imagine it is a tree structure like collections here. Okay, let me do this. Okay, collections. See here the collections, and below the collections we have the interface type. Okay, what are the interface? We have the list, and we have the set. Okay, and we have the queue. Okay, we have the queue, and inside the each and every, okay, each and every interface, again we have the array list class. Okay, and we have in the set we have as set, as I explained above. And in the queue we have the priority queue. Okay, and we also have the map as I explained to you, but it is not a part of the collection. Okay, but we have the collection, not a part of the collection, or a part of the collection. Yeah, but in the hash map we have hash map, and we have the tree map. Okay, so this is a hierarchy of our Java collections. Inside the collections, these are the interfaces, list, set, and queues, and these are the classes. Array list has set for the set. Okay, and the priority queue is for the queue. Okay, we have all in the set and the list. Okay, we'll go everyone. Now we the collections, right? Okay, this is an interface. So what is the purpose of that? That is a root of our hierarchy of these collections. Okay, basis for the list, set, and queue. This collection is in a base for all the interfaces. Okay, which are below, like list, set, and queue. This is a root of the hierarchy, and the list and set and queue for the bases are the collections. Now list is an ordered collections. Okay, list. Okay, let me write each and everything. Let me explain it like this. Okay, interfaces and their purposes. Purpose. Interface and the purpose. And the first interface we know as a collection, and the collection is the root of our hierarchy, the root of the hierarchy, and the base for list, set, and queue. It is a root hierarchy and the base for the list, set, and queue. And what is a list? Okay, list is an ordered, okay, ordered collection. It also allows the duplicates when you store the values as a 2, 3, 4. Okay, 2 is one value, 3 and 4. Again, it also allows the two value, which is duplicates, right? 2 and 2. It also allows the duplicates. Also allows the duplicates and index base. Index base. Now we have the set. Okay, set is an order and does not allow duplications. Does not allow duplicates. Does not allow duplicates. And we have the queue. Okay, and the queue is used to hold the element before processing, like first one in, first one out. Like let me use it to hold elements before processing. If the element is the first to the input, then the first in, whatever the element is the first in, that is the first one to go out. Okay, the process, and we call it as an F5 F4, which is nothing but first in, first out. Okay, first in, first out. Then a queue, and we also have the DQ, which is nothing but a double end queue, and we have the map interface, okay, which is not part of the collection, but it stores the key and value pairs. Okay, for the every value we have the key and value pairs. Okay, it's not the part of the collections, as I am repeating every time. Okay, the map is not the part of the collections. Okay, these are about the interfaces we have in our collections, and we, for every interfaces, we have different classes in that collections, and a difference, we have the difference between all this through. Okay, so which allows duplicates and which not allows the duplicates, and which in the map. Okay, there is a key and values. So in the keys will not allow the duplicate, but the values can be the duplicate in the case of maps. Okay, same ordering also. So list is an order, but set is an order. Okay, so map also maintains through its keys, and it is also like accessing the values, like index accessing. List, in the list we access through the index but not in the set. Okay, but in the map, we, by using the keys, okay, only we can access the index. Okay, and the null values are not allowed in the set, but it is allowed in the list. In the map, only one null value, like a null key, but many null values. Okay, and the basic idea of every class is they also use a array internally, but they have separate classes. Okay, in the array list they use a dynamic array internally, and in the linked list they use doubly linked list. Okay, as said, we have, so there are different types of internal working of this, all these classes, and we have the like classes in this collection, some important utility classes where we use everywhere, like sorting. For sorting we have the sort method, and for reversing we have the reverse method. Okay, and we have shuffle and min and max. Okay, for arrays, for array manipulations, we also have the arrays as a list. Okay, so we can convert the arrays to the list, and we have the performance comparisons for all those classes. Okay, now let me, okay, first let me go through the, okay, let me give the list of the classes then. Okay, after that we'll go through one example of the class. In the list we have the classes as, okay, array list. Array list, which is for accessing, it is a fast but slow in, like when you insert. Okay, when you inserting it acts slow. Okay, slow inserting and fast access. For access it will be fast, but inserting it will be slow. Array list, and we have linked list. Linked list. The linked list will act fast in the insertion and deletion. Okay, delete. But when you want to access, it will act slow. Okay, for the linked list. So reverse in the array list and the linked list, they properties are opposite. Okay, in the array list we can access fast, but in the linked list we can't access that fast because it acts slow. In the linked list it will act fast insertions, and in the array list it will be slow. And we have the vector class. Okay, we have the vectors for synchronized array list. Okay, for a synchronized array list, and we have the stack also. Okay, um last in, okay, whatever the last element will be inserted into that, okay, to that list, that one will be get out of that stack. Okay, last in first out stack using a vector list. Now set implementations in the set we have asset. This is an unordered set and uses the hash table, and we have the linked hashtag, linked asset, sorry, asset hashtag. Okay, linked hashtag, it also maintains insertion order, and we have reset, I think. Yeah, reset. Okay, it will be sorted set used red black tree in this tree set. We have map, and we have the queue also, and the queue is nothing but a priority queue. Okay, elements will be sorted. Elements will be sorted by the priority. Elements will be sorted by priority. Okay, and we have the map implementations. We have hash map. Okay, another map. This is also another map, and the hash set also another set, and we have linked hash map. Linked hash map, it will also maintain the insertion order, and same as a tree we have the tree map. Okay, same as a tree set. So just sets and maps are same name, but there is a difference between hash map and hash set, linked hash set, linked hash map, tree map, tree sets. Okay, but those are the sorted keys, but it also uses a tree that is in a sorted set. Okay, in the maps there will be key and values. Okay, these are the classes in the interfaces of the collections. Okay, now let me give you one example for you of the array list. Okay, we have also common methods in this collection interfaces, like a dot add method, like whatever you want to add the element. Okay, this will insert. Okay, this will add the element. Okay, so just like that, we have the remove method, we have the contains. It will check whether the element is present or not, the contains method, and the size will return what is a whole, how many number of elements are present in that collection, and the clear will clear all the elements. Okay, these are all the methods when you do some programming you can need to know. Okay, now first we will go with the array list. Okay, it will uses a dynamic array inside. Okay, it also array list, what I said exactly earlier, it also allows the duplications, right? Yeah, it also allows the duplicates, and it also maintains the insertion orders, which means ordered. Okay, where I written that? Yeah, see here, ordered collection allows duplications and index based. Let me do one program. This, yeah, let me share my Eclipse now. Okay. Okay, then let me create one new one. Demo SRC. Let me create in the advanced new class name as array list example. Okay, I'm selecting public static void main finish. Okay, so as I said, the collections are inside the import. Okay, Java util.packages. Okay, these are the part of the util packages. So you need to import the Java dot util dot asterisk, which means everything. Okay, now, see, if I want to take the some fruit list, let me take the fruit list. So I want to store that in my collection. Okay, that name as a array list. So I am let me create the one object. Okay, the collections are nothing but the objects, right? So let me create the object as a string. Okay, in the list. Okay, how we create the object? New array list. Okay, array list, new class. Now with this object, I want to store the data in that object. Okay, so we have, if you want to add the element to that list, we have the add method. Okay, add method. So whatever you want to store in that, you can use that. Now just like that, I want to insert oh, 3 to 4 values. Okay, one is mango, banana, DANA. What we can say as orange. Okay, now let me print it out that list. Okay, let me print out that list. So stm dot or dot print ln of list. Okay, so let me see, run as non server. Sorry. Okay, see, in the list we have apple, mango, banana, orange, and we can also, okay, after printing, let me add one more list dot add. Let me add my name in this. Okay, let's run as Java application. So here it's directly printing the list. Okay, after printing, we are adding. So print it out here. Just yeah, see here it's adding. Okay, so this will be dynamic in the nature. So this is how we use a array list. So you need to create the object of that array list, and you can use the methods, or you can, what you can do it here is, let me list dot remove. Okay, you can use the index of that. Okay, so 0 1 2 3 4. Okay, at the fourth. Okay, then let me add this another one here, list dot add. Okay, here I will add the Krishna. Okay, and I will remove the index at 0 1 2 3 4, fourth index, which is Radha, and we will print it out the list again. We will print the list again. Let me run this. Okay, see, previously the Radha was added, and then we removed that data and we added a Krishna. Okay, and we print it out. Now, let me create one more linked list. Okay, so and actually linked list is good for insertion. Okay, and also deletion. Okay, which where we use the array list for the accessing. It is fast in the access, but slow in the insertion and the delete. Okay, but the linked list, as I explained, it will be fast. Okay, elements stores in the nodes actually. So double linked, where the linked list use a double link class, so it will stores in the nodes, so it will good for insertion and the deletion. So just like this, let me create a linked list. Okay, linked list, this is a class name, and let me store the integer values. Okay, li equals to new linked list. Okay, new linked list. Now let me, with the help of that, add add integer of 21. Same li dot add integer 16. Okay, and after adding these two numbers, I want to add at the first place. Okay, at the first means add, sorry, add first, I think. Add first integer as 0 2. Okay, now let me print it out this linked list now. System dot out dot print ln of li. Okay, let me run this and we will see what it has print and see. First, I said to add the 21 and 16, but later asked the object to add at the first, so it added the 2 number in the first of my linked list. Okay, so this is how we create the linked list. So I also explained about the hash set. The set, which is nothing but an order. It doesn't follow the order of the program, but it doesn't allow the duplicate values, which means here when I use linked list or array, okay, array list, those will allow the duplications. So let me explain it here once. Okay, see, as here I will ask the li dot add 21 again. Okay, 21 again, and let me print out this, let me run this again. Run as Java application. See here we have the two values of 21, 21. But when you use the hash set, okay, see, let me create the hash set object of the integer only. Okay, then let me give the integer values only. Integer as hash set, new hash set. Okay, now with the object of the hash set, I want to add the integer, and same as the previous linked list, I want to add the first 21, and again I want to add the hash stat add 21. Okay, and it is dot add 16. Okay, it is dot add. Okay, see here it not showing the add first method because it doesn't follow the any order. Okay, so this is an order collections. Okay, now let me print it out this set. I said dot print ln of hs. Okay, now let me run this program. Java application. See, it giving me, it is doesn't following any order, it printing the values, but it also not allowing to print the same duplicate values. It's just simply giving the 16 to 21. So these are the unique values. When you want to print the unique values from any data, okay, you can use a hash set by creating that object, and you can store every data into the hash set. So you can simply print it out hash set, so you can get the unique values from the any data. So this is how we can use the different types of collections. So we have different hash maps, and it stores in the key value page. You can give the key for that, and you can store that value. So when you want to get the data, you can get it by the key. Okay, we have the methods called map.get. Okay, like create the object for that map, and with the object you can get the methods. Okay, you can call the methods. So yeah, this is about the collections. Now let me get into the threading part. Okay, so threading is nothing but when it is an ability of a program, okay, to execute multiple threads simultaneously, like which means uh, at a time doing like a 2 to 3 process, like a lightweight sub process, smallest unit of the processing. How can I say this? Yeah, the best real-time example for this is like let me write the threading. Okay, we call the threading as a sub process. Okay, the smallest unit of the execution. It allows multi-threading also, which allows multiple threads to run concurrently, which means parallelly these thread process will be goes on. Okay, if you want to perform in a 2 process or 3 process, so this thread will, what it will do, it will do the sub process and the smallest unit as a executions, and Java will support all these multi-threadings. So it will also allows all these threads to run concurrently. Okay, the main features of these threads are to use our processing unit efficiently and to save the time to run the task in the parallel way. Okay, because see here now I am using the notepad and eclipse and webex. Okay, so these are all the parallel operations we are running in our system, so it follows a threading in our system. You can go to your task manager and you can see in the cpu performance there they will use the threads. Okay, those are nothing but this is the topic where it is in a sub process of the executions of all the programs in the multiple threading. Okay, so it will save the time to run the task in the parallel, and it also uh, run the animations, and also it also runs it also supports in the downloads. Okay, parallel way. So these are main features of the threading. Actually the threading is in a sub process, is and a lightweight, actually lightweight sub process, uh, the smallest unit of the execution. We can call it as the smallest unit of execution. And the Java support is, okay, Java supports multi-threading also, which means the process is the smallest unit of executions, multiple smallest unit of executions. So that's nothing but a multi-threading. Multi-threading which allows multiple threads, multiple threads to run concurrently. Concurrently. Yeah, the main features of the threads, right? Efficient use of the CPUs, and it also save the time to run the task parallelly, and you can run the task in the backgrounds also. Like if you want to play the video game, or like you use MP3 players, okay, all those things. Okay, and it also has separate okay, for the process we have the separate memory space, and for the threads also they for the whatever the process they memory, the threads will be used. Okay, they will share the memory with the other threads also, and the communication between the process will be inter-process communications, but in the thread they are the fastest because they share the memory. Okay, and they are dependent on the main process, whatever the main process is happening, though the threads will be depend on that main process. Okay, and the threads life cycles, like it will be new. Okay, and when it will run, right? So after run, when we blocked, it will be terminated. So the thread will be created, but it will not started. When you create a thread, okay, when you create a thread, but it will not started, but it will ready to run, but it also waits for the CPU. Okay, so when it's running, it actually execute the programs, and it will also wait for the resource. So we, these some keywords we have in that. So new, like running, and the blocked. So blocked means it will waiting for the resource. Okay, so we have the waiting time also. Like for a fixed time, it will, those will wait. Okay, timed waiting, we can call it as a timed waiting. And we can terminate that thread also, like if after execution we can come, when the task is completed, that thread will be terminated. So how to create the threads in the Java, let me show you. Okay, oh, then before that, let me give you the keywords. I think no need of this. Okay, new, runnable, running, blocked is nothing, waiting for responses. Okay, so let me show you like how to create the threads. Okay, we have different methods, okay, for that, but let me do one program on that. Let me create one package, then new package, and we call it as thread pack finish. And inside thread pack, let me create one class name as main, and let me select the public static void main. Okay. Mm, yeah. Yo, let me create the custom class then. Okay. Like class. Okay. My thread extends. I want to extend the thread class. Okay, we have the thread class, right? Thread class. Now what I want to say, let me open this class. Okay, my thread will extend whatever the properties of the thread we have, that will be inherited into my thread. Okay, so inside my thread I want to create one method as a public void run. Okay, public void run. Okay, now let me print it something in this system dot out dot print ln, and I want to say the thread is running. Thread running. um, Thread running, and we have the this class, we have the methods to get the thread name, like a current dot current thread. Okay, and we can get that thread name as get name. Okay, now, okay, get name, we have created our custom thread. Okay, now we have created our one custom thread, which is known as my thread, and which will inherit the properties of the thread. Okay, the thread is built in Java class. Okay, in the Java dot language class, that is in a built-in. Okay, so that represents a thread. By using extends, we will inheriting all the functionalities of that thread class. So we are saying that my thread. Okay, so just we are creating custom thread for us. Okay, to run a program, to run a task, we are creating our own thread by inheriting the properties from the thread. The thread class is an inbuilt Java class in the Java dot language packages. Okay, now I have created one method here, public void run. Okay, so the run method is where we define that code that thread will execute. Okay, this method will be overridden from the thread classes. Okay, when the thread start, this is a first method that runs. Okay, you should not call the run directly. Okay, you have to call the start instead. When internally it will call the run method in the new thread. Okay, now see. Now let me create the object of my class, which is nothing but my thread. Okay, my thread t1 equals to new my thread, new here as my thread. Okay, my thread. Now if you want to run your program, okay, the dot run method is where we define the code that thread will execute. Okay, this is a thread. Okay, this is a thread. When you call this thread, then it will run the run method. But if you directly call that method, it will overridden. Okay, when the thread start, this is the first method that runs. Okay, you should not call the directly run method by creating the object of that class. Okay, you have to call the start method. We have the start method in the threads t1 dot, okay, start. See here we have the start method, right? So you need to call the start method. Okay, inside this what we are saying is, okay, we are taking the references of the thread which thread is running. Okay, gives the references to whatever the currently running thread. Okay, we want the name of that thread. Okay, it may be thread 0, it may be thread 1. Okay, so that line will print the name of the thread that is actually running now. Okay, now we are creating, now then we first we create an object and then we uh, started that thread. Okay, so it will tells the Java, okay, it will tells to the Java to start a new thread of execution. Okay, so this is my thread. You need to start that execution. It also creates a new call and it also execute the run method. Okay, so if we call t1 dot run directly, it would not run the main thread. Okay, it will not on the separate one, it will defeating the like process of the threads. So let me run this program. Okay, the thread names will be 1 or 0 or 2. Okay, whatever it will be. Okay, thread 0 or thread 1 or thread 2. Okay, so depending on how many threads our Java is already running. Okay, let me run this again. This is 0 only. Okay, so so here the concept, okay, here the concept of the thread is the worker will doing a task as a like a this thread will do the work like a waiter itself. Okay, serving a table. Okay, whatever the task we create, okay, it has to do, and the run method is the task of that thread. Okay, whatever the thread we created, that, okay, that will do whatever the task we are creating. Here the task is nothing but the run method. Okay, the task is nothing but the run method. Whatever, when you create the thread, that task will be, okay, the task will be performed by that thread. Okay, and we have start method. Okay, start will, it will start a new worker as a thread. Okay, but run will what actually does means it main it will run the main method. Okay, main thread only, but not the whatever we created thread. Okay, so try this threads with creating new threads. Okay, like start the thread. Okay, build some functions in the my thread. Okay, then you can use that time dot sleep. Also we can also use a sleep method. You can stop the process for seconds. Okay, then you can run to see whatever it's like. Let me start it here, like t1 dot sleep. Let me give the file. Okay, not this is an object, right? I think 1 second. Thread dot sleep. Okay, then let me give. I think I had to take this and this here. And yes, I think here it works. Yeah. Okay. Okay, this is about the threads. Okay, threads will be used for a uh, like this also supports a multi-threading, also multiple purpose. Okay, we can create multiple threads and we can run the multiple threads. Okay, and we can perform the synchronizations with also. Okay, when multiple threads access like accessing the same data. Okay, so we can create the race conditions. Okay, so like we can wait and we can use count values, and we can notify. We have the method known as a notify and notify all methods. Okay, so we have methods as a thread. Okay, we use some methods as a start method, so where it start the thread. Okay, and we have the run method. Actually, the run method is also contains in the thread by default. Okay, so when you see in my example here, if you not create, if you didn't start without starting, okay, t1 dot if I ask a t1 dot run. Okay, so let me print it out this Java application. So it's, see, first it giving you the thread running as a main, because in the thread we have default method as a run, so it is overriding this method when you call that run method. But when you started with the start method, our thread, it is running actual method in my thread. Okay, so this is some methods we have, and we have the join method, yield, and we, when you want to check the thread is alive, okay, you can use the is alive method. So this is about the collections and threadings. Okay, so this is the last class, and if you guys have any doubts regarding anything regarding Java, or up for upcoming classes, I think we will start the upcoming classes with the JSP and JDBC. I don't know whether, but I have to ask. Okay, so this is the last class for the core Java. If you have any doubts regarding anything, you can just ping me in the WhatsApp, or you can ask me in the class also. Okay, thank you everyone. Thank you, Asim.